for about 15 or 20 more minutes for additional discussion.
Okay, thanks, Yafim. I will present a paper with Yafim, Eyal, and Ori that is now forthcoming on Psychological Review. And I will also present an extension of this paper that we hope in our choice prediction competition extension that we want to run, that we plan. The starting point of our analysis, like the starting point of many of my papers in the last 20 years, is the observation that while decision research has documented robust deviation from maximization and provides interesting insight, it is not always clear how this research can be used to derive clear prediction. The main difficulty stems from the fact that the leading explanation of the distinct deviation assumes that different choice environments trigger different biases, but shed limited light on the boundaries of the different environments. So it's not clear under which conditions the different biases emerge. For example, think about the observation that many people many people prefer safe bonds over more attractive stocks and appear to suggest risk averse. But the same people, and one of them is me, tend to hold only small number of assets, which suggests that they are under-diversified and exhibit risk-seeking. The common explanation of this contradicting deviation assumes that when people consider bonds and stock, then they exhibit loss aversion, and this loss aversion leads them to behave as if they are extreme risk averse. On the other end, when people consider multiple assets, then they behave as if they are overconfident, and this overconfidence leads them to behave as if they are risk-seeking. While these explanations are insightful and elegant, it is not clear how, it's not always easy to derive prediction from them. For example, what should we predict in an environment that involves choice between multiple assets that includes bond and stock? Is that more like the situation in which people are loss averse, or more like the situation in which people are overconfident? So this is a problem. Early study of decision from experience, including my own research, tried to facilitate prediction by contributing to the development of a meta model that clarifies the conditions that trigger the different biases. In particular, the description experience gap can be described as a step in this direction. This step helps clarify why the difference between an environment in which people behave as it's an overweight or event, as in buying insurance and buying lottery, and environment in which people behave as if it's an underweight or event, as in texting while driving. In other words, and so basically the explanation that the description experience gap proposes is that in decision from description, people overweight or event, in a decision from experience, they underweight or event. So it's a step toward the meta model. Unfortunately, however, I now begin to think that this step is not very large. And as a step, the description experience gap, I think, is robust, but it's not a really good, useful step toward the meta model. Part of the reason is that it cannot explain why many people continue to buy lotteries even after gaining experience. So in some situation, you get underweighting of rare event, even in decision from experience. And more importantly, most natural decision situations, like investing in the stock market, are made based on some description and some experience. So the understanding that there might be a difference between description and experience doesn't really help you predict behavior in these settings. In the current paper, we try a different approach to address this big question. Specifically, we examine the possibility that it may not be necessary to assume that different choice environments trigger different biases, and so we don't really need a meta model. Our optimistic prediction, or hope, is motivated by three observations. The first observation is that most natural decisions like buying, investing, driving are all decisions from experience. So maybe the description and experience gap is not so important there. Second, recent choice prediction competitions suggest that the main effect of experience can be approximated by the hypothesis that people tend to rely on small sample of past experience.
Can I ask a critical question about your first claim? Most of our decisions are from experience, if we take experience in the natural language sense. But if we take it in the technical sense of what much of your group is working with, repeated observation from IID processes, and almost no decision in our real life is like that. So
No. Thanks, Peter, but we gave up the IID issue. When we talk about decision from experience, we don't have to assume IID. So although the experience I will present today will be IID, but our assumption, but we have results that is not IID, and basically our model was motivated to address situation that is not IID. I will explain that later, but thanks for this question. The third and most important observation is that the reliance, and this observation, maybe even Peter will be okay with it, which is a theoretical observation. The third and most important observation is that the reliance on small sample hypothesis predicts that certain changes in the incentive structure reverse the direction of the deviation for maximization. This reversal occurs even when the choice environment does not change. And what we want to do in this paper is to test this hypothesis. So the first part of the paper tests the prediction of the reliance on small sample hypothesis. We do that by trying to reverse 6 deviations from maximization that were documented in previous study of decision from experience. So basically what we argue that the deviation from maximization documented in previous study of decision from experience are not robust. They can be reversed, and we can actually predict the reversal by this very simple model that people rely on small sample of past experience. To be even better consistent with what Peter is probably thinking, we're going to start with a very simple and precise model of reliance on small samples. But I will first present the experimental paradigm before the model. All our experiments are going to focus on the basic clicking paradigm. In the typical experiment, the subjects are informed that the current experiment includes many trials. Their task in each of the trials is to click on one of 2 keys presented on the screen. Each click will be followed by a presentation of the keys payoff. The payoff of the trial is the payoff of the selected key. So for example, the subject selects right and gets a payoff 1. In this experiment, they're also informed that had they selected left, they would get 0. Notice that we don't tell the subject that all the decisions are independent. We tell them nothing about the incentive structure. As far as they can tell, there could be some Markov process behind the payoff or something else. Okay, so this is the experimental paradigm. All the experiments that I will present today were run for 100 trials. The participants were either in the lab, in our lab, it's a Technion, or MTurk workers. And points were converted to money using different methods, and we found that the exact conversion method has little effect on their behavior. Okay, and now here is what I mean by the reliance on small samples. I'm going to start with a very simple model of reliance on small samples, and this is the sample of 5 model. This model, this model basically assumes that when subjects come to the lab, in the first trial they choose randomly, and starting from the second trial, they base all their decision based on 5 randomly draw with replacement for previous trials. So for example, consider as the following experiment in which subject have to select between top and bottom, and the result in the first 10 trials from bottom is always 0, and from top they got +1 9 times, and in one trial they lost 10. So on average, the pair from top was negative. What would do the sample of 5 model in this prediction? So the sample of 5 model predicts that in this experiment, in trial number 11, the participant will behave as if he takes a sample of 5 previous trials randomly selected from this set, and select top only if the sample does not, is the average pair in the sample is positive. That is if the sample does not include the -10 outcome. And the probability of this event is 0.9 to the power of 5. So the probability in this case that, according to this model, that the subject will select top, although top is associated with lower average payoff, is 59%. Notice that this model is very different than models like reinforcement learning, the reinforcement learning models that I used to study in the 90s. The reinforcement learning model basically assumed that the choice propensity has some running average. So they would predict that in this case, you will be highly sensitive to the recent loss of 10. But the reliance of small sample model does not assume positive recency. It assumes drawing from all previous trials. Okay, question about this model? The reason, by the way, that we moved to study this, to favor this model, reliance on small sample over reinforcement learning, because the data do not show very strong positive recency. In this case, rather the data show a wavy recency effect, as we show in the Plonsky et al. 2015 paper. Okay, the sample of 5 model provides a simple explanation of 6 known deviations from maximization documented in previous study of decision from experience, and our paper replicates those 6 deviations. And our analysis asks if it also correctly predicts the reversal of these deviations. So this is what I'm going to do next. The first deviation that I would like to consider is a tendency to underweight rare event. Here are a summary of 2 experiments that demonstrate this effect. In the dark experiment here, the participants are asked to choose between one key that always provides 0 and the other key that lead to a loss of 10 in 10% of the trial and lead to a gain of +1 in the other trial. So the expected value of this lottery is negative. And what you see here is a choice rate in 5 blocks of 20 trials. So here is this block is from trial 80 to 100. And what we see, and this result when we first, Greg and I got it, surprised us, that subjects do not learn to maximize in this setting. They continue to select the bad lotteries that lead to large losses 58% of the time, even after 100 trials of experience. The light problem, in the light problem, the rare event is a large gain, and we see underweighting of rare event in this case too. Both results, as I said, can be described as the assumption that this participant behaves as if the underweight rare event, they do not pay enough attention to the rare outcome, and the outcome happened to be very close to the prediction of the sample of 5 model. In this case, the sample of 5 model predicts that the choice rate in the dark problem will be 59%. That is 0.9 to the 5th. And we get very similar results. Well, the sample of 5 model predict underweighting of rare event in the current setting. It also predicts that in some setting, people will behave as if they overweight rare event. For example, consider a marketer like Yafim here that try to increase the attractiveness of a low EV option by adding some small bonus. In particular, I think that the marketer wants to convince people to select L, this option L here, that on average pay 10, by giving them some bonus, and the marketer wants them to select this better option over a better option that provides 12. And the marketer considered 2 bonus systems. One is to give 1 for sure. Each time you buy L, you get +1. You select L, you get +1. Or give you a lottery that with probability 0.1, you're going to get 10. The sample of 5 model predicts that in this case, people will behave as if they're overweight rare event. Why? The dark bonus is not going to affect them because only if you get this bonus, you get from selecting L 11. In all small sample, 12 is more than 11. However, this bonus might work. The reason it might work because if your sample include the +10 outcome, then you might go sample of 5 agents will select L. And this is what we see in the experiment. So in this case, so the same model predicts here underweighting of error event, and in this case, it predicts overweighting of error event. And I think that it is possible that I like this result because it's helped me it's provided sufficient explanation for why people buy lotteries. Basically, we think that people buy lotteries despite the fact that in experience, they most of the time underweight their event, but once in a while they feel lucky. This plus 10 get into their sample and then they buy lotteries. This is our explanation for buying lotteries. The next known deviation that I would like to consider is the existence of overconfidence or reverse loss aversion. To clarify this effect, here is our application of this effect. In this experiment, the participants are asked to choose between status quo, an option that gives 0 for sure, and 2 risky options that provide a gain or a loss. The medium risk option give a gain or loss of 4, and the high risk option give a gain or loss of 8. Notice that in this experiment, the 2 risky options are negatively correlated. When one of them leads to a gain, the other one leads to a loss. The sample of 5 model predicts that in this case, so the leading model like prospect theory and expected utility theory with risk aversion predicts that people will prefer the status quo. But the sample of 5 model predicts the opposite. It predicts the opposite because of the negative, due to the negative correlation between the 2 risky prospects, the status quo is never the best option. So if you rely on sample of 5, you will never conclude that the status quo is your best option, and these are the experimental results. The status quo rate in this experiment is only 12%. Yet, when we reverse the correlation between the 2 risky options, the sample of 5 model predicts that very different pattern, predicts that in this case, the subject will behave as if they are loss averse. And the reason is that once you have positive correlation between the 2 risky options, option R is nevertheless the best option. If you are lucky, it's better to select high risk, and if you are not likely, it's better to select the status quo. So R is never the optimal choice, and this is what we see the result. So in this case, when you compare R and status quo, you can conclude that the subject behave as if they are loss averse. So we get this reversal, but we don't have to assume different biases. The same model predicts the 2 effects depending on the correlation between the risky options. The third phenomena that the same known deviation that I want to explain and then to show its boundary involve a boomerang effect of taxation. Consider now a manager that knows that his workers, the worker in his factory, have to select between 3 can select between 3 strategies. A safe strategy that leads them gives them a payoff of a payoff of 0.6 with certainty. An attractive risky option that gives the workers a payoff of 1.6 in 97% of the time, but lead to an accident that costs them 20 points otherwise. So the expected value of this risky option is better for the workers, but from the manager point of view, the accidents are even more costly. So he wants to reduce the tendency of the workers to select this medium risk, this attractive risky option. And he wants to do it by introducing a taxation that reduces the payoff from the attractive risky option for 1.6 to 1.2. What will happen due to this manipulation? And the sample of 5 model predicts that this manipulation will backfire. That is, despite the fact that it reduces the attractiveness of taking risks and make safe the optimal option, agents that rely on small sample actually will take even more risk and this will increase the accident rate. And this is what we find. The reason that the sample of 5 model predicts this boomerang effect is because the taxation moves people from the attractive risky option, in which the probability of accident is only 0.3%, to the high risk option, in which the probability of an accident is 6%. The same model also predicts that under certain situations, people will exhibit overreaction to taxation. One example happens in this situation when the tax reduces the probabilities that the desired choice lead to the best payoff. In this situation, the participant have to select between extremely highly attractive options that provide with expected value of 2.98 or the status quo. And the taxation reduces the payoff from the attractive option by 2, but it's still highly attractive. It pays almost 1 when the status quo pays 0. The results show, however, that this taxation dramatically reduced the choice of the attractive option, the high expected value option, reduce it from 91% to 30%. So in this case, taxation backfire. And again, we get all these results with the same simple model. You don't have to assume that the choice environment trigger different biases. In this example, these are 3 examples, and our paper shows 3 additional examples that show the same pattern. So here's a summary of the experimental result. I don't have time to discuss all 6 contradictory deviations, and I will now summarize the experimental results. So basically, the result demonstrates that the emergence of contradictory deviation from maximization that demonstrated contradictory deviation even in a fixed choice environment. This observation suggests that it is not necessary to assume that the choice environmental biases, to assume choice environment-specific biases to capture this deviation. All the results can be captured with a simple model that assumes reliance on a small sample of past experience. Notice, however, that the sample of 5 model, while it's capture all the 6 deviations we consider and correctly predicts the reversal, it's not exactly accurate. Its quantitative prediction tend to be too extreme. For example, in this problem that I've shown you, the sample of 5 model predicts 0% and 41%, while the observed results were 12% and 22%. What we do in the second part of the paper to try to find a model that provide better fit, quantitative fit for the data. Comparison of alternative abstraction highlights the value of 2 assumptions that can be added to the sample of 5 model. The first assumption is just variability in the sample size. It turned out when we looked at individual differences, we found very large difference. Some people behave as if they take large sample, and some people take as if they rely on sample of 1. So adding variability helps. Not everybody uses sample of 5. And in addition, we think that the results can be fit can be improved by assuming that in addition to relying on past trials in the current experiment, the participant also rely on old past experiences. Here is the best model that we could find. We called it the partially attentive sampler. This model assumes that the participant rely on 2 types of past experience. As I said, all the experience that occur before they arrive to the current experiments, and also new experience, that is experience that occur in previous trial of the current task. In addition, this model assumes that the probability of reliance on old past experience diminish with experience in the new task. In particular, we use the probability of using old past experiences given by this function. So in the first trial, the participants have to rely on old past experience. They still don't have new experiences. So, and then it goes down and reaches some asymptote at a free parameter delta. In the current experiment, when the participants do not have prior information about the 2 options, we assume that when they rely on old past experiences, they have something in their mind, but from our point of view, they basically choose randomly because we don't know which past experience they bring to them to the lab when the 2 keys are unmarked. When the agent is attentive, he relies on kappa past experience in the current tasks. When we estimate the parameters that best fit our data, we find that the best fit is obtained there is large variability. The median parameter are 4 past experiences. This is the median. And the delta parameters is error rate in the long run, or generalization rate in the long run is 0.2, but there is huge variability. In particular, about 10% of the participants behave as if they rely on only on old past experiences. And about 80% of the participants behave as if they rely on old past experience in the current experiment. This model with 2 parameters fits the data very well. Here are the example how it fits the experiments that I've shown you. So you have to trust me that it fits well, but we also compare it to other models, and we consider 9 alternative models. 5 alternative abstractions of the reliance of small sample hypothesis that I will not present today, but are described in the paper. The reinforcement learning model proposed by Spector et al. In a recent Psych Review paper. And we also consider a 2-stage prospect theory, 2-stage expected utility theory, and 2-stage portfolio theory. The 2-stage prospect theory, for example, assume, like the Taylor et al. 97 paper, basically assume that the participants first use past experience to estimate the pair of distribution, and then use prospect theory to derive behavior. Our results, and we compare the models based on 2 analyses within individual comparison that focus on 691 participants who faced 2 tasks. We estimate the parameter of each participant on 1 task and then evaluate the prediction on a 2nd task. In addition, we ran a between group comparison. So this comparison, which is our favorite comparison, we first derive the prediction of this model by estimating their parameter on 1 set of 89 tasks, and then compare the prediction for a new set of 120 new choice tasks. After deriving, we ran this additional 120 experiments only after deriving this prediction, and they were pre-registered. The results of both conditions revealed that a small difference between the different sampling models. All the sampling model fitted the data much better than all the other model, and the model pass had only a small advantage over the other sampling models. So we are not sure what is the optimal abstraction of the reliance of small sample hypothesis, but all of them provide very good predictions. But of course, the difference between them were very small, but I will not discuss them today. Another interesting finding, serendipity that we found here, come from analysis of individual differences. As I already said, when we estimated the parameter of different individuals, we find huge variability. As I said already, about 10% of the subject behave about 80% of the subject behave as if they do not rely on small samples. They behave as if they are fictitious players. They use all past experiences to in each trial, but many behave as if they rely only on 1 sample. We also find large variability to the extent in which they they use old past experience according to our model. So the median parameter were 4 and 0.2, but we have this huge distribution. The surprise was that when we looked at the participant that participate in 2 conditions, and we use a parameter estimate in 1 condition to predict the behavior of the same participant in the 2nd prediction, this method did not provide useful prediction. It was a model that assumed that the participant redraws a parameter from this distribution when they face a new task perform better than the models that assume consistent stable parameters. Many psychologists, when they get results like that, they said something wrong in your model. If the model doesn't have parameter stability, the model probably doesn't describe real processes, but we think otherwise. And let me explain why. One explanation for the lack of parameter stability come from the idea that it's come from the view that the descriptive value of the reliance of small sample hypothesis reflect the impact of processes that resemble classification algorithm used in machine learning algorithms. That is the model. Basically, this explanation said that people rely on small sample not because they have some cognitive limitation, but because they are trying to discover some pattern. Here is an example that demonstrates that. Think what you would do in trial 16 of the following experiment. In this experiment, again, as in the previous example I presented, bottom always pays 0 and top give a gain or a loss. In this example, top lead to a loss in the first retrial and then to a gain. Again, loss in 3 trials and then a gain. What would you do in trial 16? Our analysis suggests, so we actually run experiments like that most participants, that is, participants who did not teach statistics for too long, tend to select top in this experiment. That is, they behave as if they think, like, notice that the average pair from top is negative, but they still select top in trial 16, and the reason is, or the intuition is, that they feel that they discover a pattern. They notice that every time after 3 minuses, the plus 2 comes. So they feel that it's about time that the plus 2 will come. So basically, we suggest that people behave as if they rely on small sample, not because they rely on small sample, but because they are trying to look to some pattern, and this effort to discover pattern lead them to behave as if they rely on small sample. So here is a summary of this paper in Psych Review. Basically, we think that the result demonstrates the emergence of contradicting deviation from maximization, even in a fixed choice environment. This observation suggests that it is not necessary to assume environment-specific biases to capture the deviation we study, and the reliance on small samples explanation provides sufficient explanation. In addition, we think, as our previous research suggests, that the descriptive value of the reliance on small sample hypothesis can be the product of classification-based processes that resemble machine learning algorithms. And this is basically my answer for Peter's question earlier. I don't think that people rely on small samples because they think that the environment is IID. The other way around. I think that what's happening here is that we were evolved to survive in a dynamic environment. And the way we do it is like machine learning algorithm. We are looking for pattern and select best reply. And while doing that, and one implication of that is that when the environment is static, then it seems that we rely on small samples. But when the environment is dynamic, basically this process is likely to discover useful pattern and to approximate the optimal behavior, even when the optimal behavior is complex. We show that in the 2015 Psych Review paper, Plonsky et al. Paper. Okay, that was the first paper. Let me now move to the extension. And Yafima will take question in the end, right? Not right now. Let's move for the extension and then I'll take questions.
Whatever you prefer.
Okay, let me move for the extension. So the extension, again, in the spirit of this machine learning story, we would like to shed light on the joint impact of verbal nudge and experience. This is a pilot study that we hope will lead to a choice prediction competition. Basically, the starting point of this follow-up paper is that the observation that it is not necessary to assume that the choice environment changes the underlying processes does not imply, of course, that the choice environment is ignored. What we want to do in this follow-up paper is to clarify the impact of the choice environment. And in order to do that, we chose to study the joint impact of verbal nudge and experience. In particular, we're going to run we already ran some pilot studies of the following spirit. Basically, these experiments are variant of the experiments I already showed you, but this time we're going to nudge the subject to select one of the key. So here is an example of one nudge. The nudge says, this key prevent losses. And the nudge are honest. If you select this key, in fact, it guarantees that you will not lose money. So we nudge them, but we are not lying. Here is another nudge. This key is selected by most participants. And again, it's not lying. We already ran this experiment on, and notice that most people select that key. Notice that the model pass that I just present can be naturally extended to address a situation of this type. It is enough to assume that the verbal nudge, recall that that pass assume that the participant rely on new experiments in the current experiments and also in old on experiments that occur before the current experiments. So under pass, this nudge, for example, prevent losses, that remind you past experiments that you saw similar nudges. So if you rely on old past experience, this nudge will affect your behavior. Okay, so we can derive prediction from past for this setting too. Let me show you results of 2 experiments. These 2 experiments used this nudge prevent losses. And this nudge was written on the safe option. In fact, in this option, you did not. There was no losses. The blue line presents the choice rate in 100 trials with the nudge. This is the very first trial, this point here, and then you see the 5 block of 20 trials. As you can see, the nudge has larger effect in the very first trial, but the effect almost diminished in the first block, but then it's remained, it did not disappear. This results a little bit surprised us, but it seems that the nudge is pretty robust. It stays, it increased as a choice rate of the safe option. It increased it from about 35% to about 40%, or from 32, more accurately, from 32 to 38 or something like that. To clarify the impact of the nudge, we also run this extreme experiment in which the safe option, again, led to 0 for sure, and the risky option now led to a loss, was really bad option, led to a loss of 800 with probability 0.1, and led to a gain of +1 otherwise. Note, this experiment will run using, we gave the participant for show-up fee in points of 10,000 points. So they could lose 12 times and still be on positive side. And we told them that the number of points they have in the end will determine the probability of winning a bonus. What we see here that the subject selects safe more, but not much more. And but the one interesting finding, it appears that the impact of nudge is a little bit larger here than here. This difference is not large, but it's significant. So here the nudge increased the choice rate by 5%. Here it's increased the choice rate of the safe option by 10, and this difference is significant. Now we examine the prediction of pass in this case, and pass fit capture with, of course, with a parameter estimated in the previous study. With only things that we did, we estimated the generalization based on what happened in the first trial. So the first trial we just was fitted, but all the rest was based on the prediction of pass. And what we see here is that pass capture the results here, but it's under predict the impact of the nudge here. When the nudge is very useful, pass under predicted. We run another experiment now with what Taylor would call a sludge. In this case, we wrote on the riskier option, we wrote the sludge selected by most participants. It's a sludge because this option minimizes impaired maximization. So it's we did not lie, but we direct them to the option that minimize expected value. And in this case, the sludge was not effective. The subject kind of learned to ignore it very quickly. They were sensitive in the first trial, but starting after 20 trials, it did not increase the choice rate. Pass does not capture this effect. So basically, we can do better. Basically, what we think is happening here is that the impact of nudge is not stable, as actually the nudge literature show that you find some positive effect of nudge in short experiments, but in long experiments, the impact diminish. But one optimistic finding for nudge people that the effect in our setting remains. It's not very large. It's very hard to detect in field experiment effect that is only 4%, but it remains. And pass approximates the impact okay here, but definitely should be improved to capture the impact of nudge of that sort. What we want to do in the next competition that we're going to run is to improve the prediction, to encourage people and to do it ourselves too, to try to find the models that can predict the joint impact of this verbal nudge and past outcome. So, for example, the task in our next competition will be the participant will be the participant in the experiments will see two keys, one of them with a nudge, and the people who want to predict their behavior, the researchers that will participate in the competition itself, not in the experiment, their task will be to predict choice behavior, knowing past outcome and also knowing the nudge. Okay, so we're looking for models that can predict the interaction between the nudge and the impact of past experiences. Okay, so here is my summary. Classical decision research assumes that different choice environments trigger the use of different choice rule. In accordance with this view, the nudge method tries to architect the choice environment in order to nudge specific behavior. To derive clear predictions, this classical approach requires a meta model, but the progress towards this model is slow. We propose a different approach, and specifically what we think is that the study of decision from experience highlights the potential of this approach. It shows that simple abstraction of the way people react to experience provide clear prediction of the direction of the deviation from maximization. And we also think that the STEM approach can also help predict the impact of partial description like verbal nudge, and can help predict the impact of nudge, and also predicts the interaction between the impact of experience and the impact of some prior description. And our competition will focus on this goal. Okay, that was my story that I ran, but we now have time for questions.
Thank you, Ido. Okay. So now those of you who have questions, please stand in line. And Ido will try to answer them.
Yafib, you're gonna collect questions?
Yeah. I think Eldad has one question, right?
Yes. Okay. Just to clarify, your nudge research is interesting and novel. And I was wondering, do you pay any attention to the verbal contents of the nudge, or is the model totally blind to it?
Okay, so in the first competition, we're gonna only focus on 6 nudge. So the participant will see the impact of this specific nudge in the training data set, and then will be asked to predict how it will do with different incentive structure. So, yeah, we are not thinking about something more fancy than that. But I think that NLP system research eventually will be able to tell us, once we understand how the interaction between the initial reaction and the feedback works, and we understand what happened for this 6 specific nudge, maybe later with NLP method, that is natural language processing, we will be able to generalize the results for any verbal description and any set of feedback. This is our plan. But in the first competition, we're going to be more modest and only focus on 6 specific nudge, like the most famous verbal nudge that are used in the literature. So Yafim, do we have more questions? Or does that answer your question?
I don't see more questions as for now, but I will ask a question if it's fine. Can you please elaborate a bit more? Maybe I missed this part about the sampling from previous experiences. That you said that there are 2 basically types of sampling, right? But can you elaborate on this part?
Yeah, so basically, I think that what it's easy to see in this experiment here when something is written on the keys. So I think that when the subject comes to the lab, initially, the first trial, most subjects say, oh, this, if the description here is prevent losses, they still don't have any experience in the current experiment, but initially they say, oh, I should select the ones that prevent losses. I don't like losses, right? I even learned in the introduction to psychology that people are loss averse. So they avoid this. So 74%. The other people read Eldad's paper and they actually select the key 26%, the one that does not prevent losses. I argue that that later, after they lost 10, they say, they think, oh, it's only loss of 10. It's not such a big thing. So maybe some of them think, again, those people who read Eldad's paper, they say, oh, the loss is only 10, and I also heard a talk by what is guru, this new guru, I forgot her name, doesn't matter. There is a guru who said that if you don't take risk, you're not going to get anywhere in life. If you cannot suffer losses, she's even more convincing than Eldad. So some people say, oh, based on past experience, I have this experience that when I did something that led to loss, I eventually actually earned a lot. I would never meet my lover without taking this loss. So these people, when they consider this old experience, they're actually going to select the key that says prevent losses. But eventually, according to our experiments, they say, okay, maybe it's not now that when I have more experience in the current settings, I will rely less on the old experiments. I will rely, when I'm trial number 92, I will rely more on the last 91 trials in the current experiments. And I forgot my old experience with my lover and whatever other past experience that I have. So basically, we do not give up the assumption that people like machine learning algorithms do what works in similar situations in the past, but we relax the assumption that they only rely on past experience in the current experiments. They rely on past and older past experience as well. Okay, so this is basically the model.
David, you have a question? Yes, thank you, Ido, for the
I'm muted.
clarification.
I'm sorry, I was muted. So if I understand correctly, first of all, you do very nice work, and I really thank you very much for a great talk.
By the way, Peter asks that people will not say nice talk. But David, you are the editor of Decision, so you're allowed to do that. But this was the last allowed compliment.
Maybe I can add, I think if a question and answers are preceded by compliments, it quickly becomes cliche and everybody starts doing it. It's happening more and more. Let us fight against this bad equilibrium.
All right, okay. I accept.
Sorry, David, I'm sorry, I'm not related to why they got on you.
Okay, so
by the way, Peter is not married. If he would marry, he would know that this is not it's only equilibrium. It's not a bad equilibrium.
Okay,
right,
you win, Ido.
But I would agree with you.
My question is that if I understood correctly your analysis between the friction or tension between 2 types of experiences, that maybe that suggests that you should try to look at experiments where the nudge that you have right there isn't there from trial one. So you allow people to gain experience in the current task, and then at some point you add the nudge. So you can, so to speak, control the balance between the task-specific and the task-specific experience and the effect of the nudge. That's just a thought I had, if I understood you correctly.
Yeah, well, there is a paper by Greg Barron, my ex-student, that actually field research, but also lab experiment that show when you give a warning nudge later, it has little effect. But this definitely is an interesting question. So in one experiment that Greg and his cohort ran, it's actually field experiments. They check what happened when you put a warning on a syrup for kids, for babies, that should not give it to babies below age of 2. And they basically found that new parents actually took this nudge seriously, but parents who already had one kid, they ignore this nudge altogether. So I agree with you that it can be interesting, but I think that the effect of nudge, you see, is not very large even when it's presented early on. When it's going to be presented later, my feeling it will be even weaker. So if we want to do, so we're going to start with a maximal nudge effect that we can have, and then we can look at different extensions. Thanks.
I have another question. So my
Sure.
question is, when are you going to take this paradigm of clicking and so on to move beyond just the two, a binary choice between two, and to extend it to situations where we actually have 4 or 5 clicks, buttons to click on?
Well, first, you know that I'm a economist wannabe, and economists only, the country system is 1 too many. So we actually have 3 keys here. In this experiment, many of them, this paper focus on 3, but we also have studied with multiple, and I think this is an interesting issue how to extend it. But we already, I agree with this is interesting. But one really interesting question is people say that I recently heard someone say that what's nice about behavioral decision research is provide insight, unlike some other studies that do not provide insight. And the question, what is insight if it cannot help predict behavior? What I want to do is to have insight, that is to be able to summarize the results in a sentence. This is what people like, and also to be able to predict behavior. Our model for multiple alternative makes it a little bit different to provide simple summary, but we have papers that do that. And I agree, it's a really important question.
Thanks, David. Any other questions? Because I have one additional new one, if there's someone before me. So I will go ahead as for now with my question. Ido, can you please elaborate if I want to participate in the competition, how exactly will it work?
Yeah, so we are still not sure if we're going to run it now or in the summer. We're probably going to try to be quick. But basically, the idea is that we will run about 120 experiments of the following sort, that we will use different incentives. So each experiment, we will randomly choose one of 6 nudge. One of them will be prevent losses. Another one will be selected by most user. And a certain incentive structure with 2 or 3 alternatives. And then present the choice rate, the result of say 60 participants in each one of the 120 experiments. Next, we will plan to run another experiment with another set of 120 problems, and each problem will be associated by 12 parameters. One parameter is what is a nudge, and the other one and the other 11 will determine the pair of distribution and the correlation between the pairs of different options. And the task of the participant in the competition will be to submit a computer program that reads a parameter of the problems and predicts the choice rate of each of the participants in the new experiments. We consider also to provide individual data on the individuals. We will measure the participant's risk attitude using the whole Lowry method and some other measure of individual difference, some maybe intelligence test. And the challenge will be to predict the behavior of each individual in each of these experiments, to predict each of the choices, 100 choices of each individual.
Thanks, Ido.
You're welcome.
Okay, guys, I think we are right on time. So unless there are any additional questions, I would like to thank you for this talk and see you in the competition.
Yeah, and I will stay here if someone wants to ask me specific questions.
Cool.
Can I ask a small
Sure.
question?
Sure.
Hi there.
Sure.
Thanks for the talk. What's the baseline model? Are you going to use BEAST again?
No, because we are not gonna. BEAST was designed for very specific description, right? The description of the exact pair of distribution. We think that when the description will be nudged, maybe we can use simpler model. And we also hope that maybe the simpler model eventually will be able to be generalized to some simpler variant of BEAST. So we are looking for a simpler model here. I think that BEAST is a very good model, but not many people used it because it's a little difficult to estimate. So we are thinking, can we come up with a model that is as good as BEAST for a wider set of situations? This is a hope. I'm not sure that we will be successful, but this is a hope.
Thanks.
Okay, let's see. Now there's some, not everybody is Hebrew speaking, so let's continue with Hebrew.
Yes. I think we can stop the recording.
Yes, definitely.